With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Today's question is if AR is equal to this matrix and limit n tends to infinity, summation r is equal to 1 to n, determinant of AR is equal to. Then we need to find this thing, right? We are given this matrix, then we need to find this. So we are given a matrix, so we are given that AR is equal to, that is equal to matrix which is 1 upon r into r plus 1, then 1 upon 3 raised to power r, then 2, and then 3. This is the AR matrix. First we need to find determinant to solve this thing, right? So we will find determinant of AR. That will be equal to 1 upon r into r plus 1 into 3 minus 2 into 1 upon 3 raised to power r. Okay. Now what we need to evaluate, we need to find the limit n tends to infinity, summation r is equal to 1 to n, then determinant of AR. So determinant of AR is equal to this. So this will be equal to limit n tending towards infinity, summation r is equal to 1 to n, and then here we will be having 3 upon r into r plus 1 minus 2 upon 3 raised to power r. Okay. So how we are going to solve this? First we will solve this much part with summation, and then we will evaluate this part with summation. So summation into this and then to this. So first we are going to solve this, and in the last we are going to put the limit here, right? So we are going to start with this, that is summation of r is equal to 1 to n, and here we are having 3 upon r into r plus 1. So this is 3 is constant, it can be written out. Then here we are having summation r is equal to 1 to n. In the numerator we are having 1. So what we are going to do is we are going to do plus r and minus r. Okay, minus r. And here we are having r into r plus 1. So this will be equal to, 3 into, this is summation of r is equal to 1 to n minus r upon r into r plus 1, then plus we are having this r plus 1 into r plus 1. Okay, and to avoid this confusion we can take this bracket here because summation is with both of these, right? Now what we will have here, we will take summation out. So 3 summation r is equal to 1 to n. Then in the bracket what we are left with, here we are left with, after taking LCM, this is 1 by r minus 1 upon r plus 1, right? So this thing can be written by 1 by r minus 1 upon r plus 1. So that is equal to 3. Now we will apply summation here. We'll put r is equal to 1. This is 1 by 1 minus 1 upon 1 plus 1, that is 2. So 1 by 1 we are going to put here the value of r 1, 2, 3 till n. So this is 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4, and so on till 1 by n minus 1 upon n minus 1. So we can see all these consecutive terms are getting cancelled, right? And so on. So here what will be left is, this will be equal to 3 into 1 will be left, and the last term, that is 1 upon n plus, this is plus 1 will be left. On simplifying this we can write it as 3n upon n plus 1 on taking LCM, right? So this is what, this was the value for summation r is equal to 1 to n 3 upon r into r plus 1. Okay, this here it was continuing. So this is coming equal to 3n upon n plus 1, right? Now next thing, its value we have evaluated. Now we are going to evaluate the value of this thing. Okay, so it will be, this is 2 we will take out. So summation r is equal to 1 to n, and here 1 upon 3 raised to power r. So if I put here the values for r, this is 1 by 3 plus 1 by 3 square plus 1 by 3 cube plus so on till 1 by 3 raised to power n. So this is what, this is forming a GP, geometric progression. So its sum is given by Sum of GP is given by the formula A into 1 minus R power n upon 1 minus R. So A is the first term. So here first term is 1 by 3. So we will put here 1 by 3. And R is the common ratio. So divide this by this. So what we're getting the ratio as, this is 1 minus 1 by 3 power n, 1 by 3 only, and this is 1 minus 1 by 3, right? So on simplifying this, what we are getting it, see 2 was multiplied here, 2 into this summation we did, right? So everywhere this also 2 is multiplied here. Okay, so what we are having, so we'll multiply 2 here also, or in the end also directly we can multiply because here 2 is present, right? So this will be 2 into, and here we are having 1 by LCM to 3 minus 1, that is 2, so that is 1 by 2 will be out, and then 3 will come up, so 3 and 3 will get cancelled. So here we have 1 minus 1 upon 3 raised to power n. Okay, so basically this thing is coming equal to this. So we will write that the value of summation r equal to 1 to n 1 upon 3 power r is coming equal to 1 minus 1 upon 3 raised to power n. So this is the second value which we have obtained. Now we'll put both of these in that equation. So the equation was that we need to find this value, limit n tends to infinity, summation of this r is equal to 1 to n and 3 upon r into r plus 1 minus 2 upon 3 raised to power n. Okay, so this is coming equal to, put here the values, so limit n tends to infinity, this is 3n upon n plus 1 minus, this is 1 minus 1 upon 3 raised to power n, 3 raised to power n. Okay, now if I put the limit here, this will be infinity upon infinity, and this will also be what? This will be whole 0, right? If I put n here, so 1 by infinity, this will be 0. So what we are having is, for this we are going to use L'Hopital's rule. Using L'Hopital's rule, we will differentiate numerator and denominator separately. So here we will be having this as 3 into, this will be 1 upon 1 and this will be minus 1, the differentiation. Okay, so this whole term is 0, then here we are having minus 1 and then differentiation. So what we are getting here is, we are getting this equal to 2. So the value for this expression is coming equal to 2. So therefore we can say that limit n tends to infinity, summation of, this is mod determinant of AR is coming equal to 2. So this is the required answer. Let us check the options now. So option number 2 is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.